Hey guys, this is 5.2. We're continuing with exponents and a few more exponent rules. Then we're going to use all of the rules in practice examples. All right, so the power rule is if you have one base raised to a power within parentheses, so A is the base, M is the power. If you have one base raised to a power within parentheses and raised to a second power, N outside the parentheses, keep the base and multiply the exponents. So that would be M times N. So the way I would read this is A to the M raised to the N is solved by A to the power of M times N. And that's the power rule, okay? The power of a product rule is simply the distributive property. When you have two different or more bases within the parentheses and one exponent directly outside the parentheses, you're going to distribute that exponent to both the bases. So AB to the power of N can also be written as A to the power of N times B to the power of N. So you can distribute your exponent, and same regardless of whether it's multiplication or division. A over B to the N can be written as A to the nth power over B to the nth power, okay? Everything directly outside the parentheses gets applied to everything inside the parentheses, which is a rule whether you're working with exponents or anything having to do with parentheses, okay? So let's use that to simplify each of these expressions. Here we have y to the second power raised to the 8th power, okay? That means we have y to the 2 times 8th power, which is y to the 16th, okay? B, we have 3 to the 3rd power raised to the 2nd power, so that would be 3 to the power of 3 times 2, which is 3 to the power of 6. If I put 3 to the power of 6 into my calculator, I get 729. Okay. And let's just show that. 3 to the power of 6 is 729. I can also check that 3 to the power of 3 raised to the 2nd power. Oh, sorry. 3 to the 6th power is 729. 3 raised to the 3rd power. Oh my gosh. 3 raised to the 3rd power raised to the 2nd power also gives you 729. All right. 6 to the 2nd power raised to the negative 1st power. So that becomes 6 to the 2 times negative 1, which becomes 6 to the negative 2nd power because 2 times negative 1 becomes negative 2. And then I move that down because I can't have a negative exponent. So it's 1 over 6 squared, which we know is 1 over 36. Okay. And you might be wondering if this is 6 to the 2nd to the negative 1st, and I know that anything to the negative 1st power. Oh, sorry, no, nothing. Never mind. Keep going. All right. So 6 to the 2nd to the negative 1st is 1 over 36. All right, now we just have an x to the negative 5th to the negative 7th. That means x to the power of negative 5 times negative 7, and negative 5 times the negative 7 becomes a positive, right? And 5 times 7 is 35. That's as simple as I can make that. That is all I know. Example 2, use the power rule to simplify each expression. Write each answer using positive exponents only. And remember, the power rule just means distribute the exponent to everything, okay? So take that 3, distribute it to the 3 and to the x to the 4th. Take that 2, distribute it to the 4 and to the 5. The 4 goes to the 2, the x, the y, and the 3, okay? The 2 goes to the 5, the x, the y, and the z. So if we were to do that, I would say 3 to the 3rd times x to the 4th raised to the 3rd. So I have to multiply 4 times 3, okay? 3 to the 3rd power gives me 27. X, 4 times 3 gives me 12, so it's 47x to the 12th. Okay. Letter B, 4 to the 2nd over 5 to the 2nd. So I just wanted to give the 2 to everything. 4 times 4 is 16, 5 times 5 is 25. Okay. Here we have a 4, we're going to give it to the 2, to the x to the 4th, to the 3, and to the y to the 5th, okay? So we have 2 to the 4th times x to the 4th to the 4th over 3 to the 4th times y to the 5th to the 4th, okay? 2 to the 4th, that just means 2 times 2 times 2 times 2 becomes 16. X to the 4th means x 4 times 4, right? 3 to the 4th is 81. Y to the 5th times the 4th. So I'm just going to simplify it one more time. 16 x, 4 times 4 is 16. So I have 16 x to the 16th. And on the bottom, I have that 81. And then y, 5 times 4 is 20. So my final answer is 16x to the 16th over 81y to the 20th power. Okay. Same thing here. Take that 2, give it to every part of the equation. Okay. -5 squared becomes 25, right? Because -5 times a negative turns into a positive. So that's 25. X 3 times 2, y 2 times 2, z 4 times 2. So now I have 25. 3 times 2 is 6, x to the 6th, y to the 4th, z to the 8th. And that's as much as I'm able to simplify each of those, okay? So here are our answers. We have 27x to the 12th, 16 over 25, because there were no x, or there were no variables, 16x to the 16th over 81y to the 20th, and then 25x to the 6th, y to the 4th, z to the 8th. Let's look at all the exponent rules from the last lecture and this one put together. So for product rule of exponents, a to the m power times a to the n power is a m plus n, right? The power rule, a to the m power raised to the n power is a to the power of m times n. The power of a product means I distribute that exponent to both of the variables. And then same for power of a quotient, distribute the variable to both of the, or sorry, distribute the exponent to both of the variables. The quotient rule a to the power of m over a to the power of n is a to the power of m minus n. 0 exponent, anything to 0 equals 1. Unless a is 0, then it's just 0. For a negative exponent, we make a reciprocal. Remember, this is called a reciprocal. We move it across the division bar. Okay. So now we are going to use all of these rules kind of mixed together to just solve some examples. Okay, so let's simplify the following expressions. We're going to distribute the -2 to everything inside the parentheses. So I have a 2 to the -2, x to the 0 to the -2, y to the -3 to the -2. Okay, and we're going to do parentheses. We're going to distribute those parentheses before x, before raising x to 0, for example. Okay, because we know from here that that would just be 1, but we want to distribute the parentheses before we do exponents. All right, 2 to the -2, x to the 0 times -2, y to the -3 times -2. Okay, 2 to the -2. I'm just going to write it one more time. 0 times -2 would just be x to the 0, right? -3 times -2 means y to the +6. Okay, and before I change this to a number, I'm going to move it below the fraction bar. Okay, so I'm going to leave, well, x to the 0 we know is just 1, right? 1, y to the 6, those were all positive or neutral. And then we have 2, and it becomes a +2 because I moved it across the fraction bar. 1 is just 1, right? So I can just leave that off and just say y to the 6th over 2 times 2 is 4. So our final answer is y to the 6th over 4. Okay. And the other one, x to the -5th to the -3rd over y to the -2 to the -3rd. All right, x to the -5th times -3rd over x to the -2 times the -3rd. 5 times 3 is 15, right? So we have x to the 15th over 2 times 3 is 6, x to the 6th. Okay, and remember, if you picture this, it's 15 x's being multiplied, right? And then down here, it's 6 x's being multiplied. So how many can we cancel out, right? So if I had 15 x's here and 6 x's here, I can cancel out, let me show you. 15, see if I can fit 1, 2, 3. So I've got 15 on top, and I've got 6 on the bottom. And I want to simplify this, right? That means I can cancel them. So 6 on top and all of the bottom ones cancel each other out, right? Because x divided by x just becomes 1, 1, 1, 1. So they're no longer x's, they're just 1s. So it's basically like taking 15 and subtracting 6 from it. And I just get x to the 9th. If I counted all these, there would be 9 left over. Okay. So here our final answer is y to the 6 over 4. Here our final answer is x to the 9th. Example 4, we're going to simplify each expression and write using positive exponents only. Okay. So we have 3 to the -2 over 5 to the -2, right? That's what we mean by distributing it. And then, because it's a negative, we want to move it across the fraction bar. So the 3 goes down, the 5 goes up. So now we have 5 to the second. It becomes positive when you move it across over 3 to the second. That's 25, right? Over 9. Done. All right, this one. Oh, there's all we need to do to simplify is get rid of the negative exponents, okay? So to get rid of that -2, we just moved 3 to the bottom. To get rid of that -2, we moved 5 to the top. So 6 has a -2, so I'm going to move it to the bottom. Y has a -6, so I'm going to move it to the top. And this X also has a negative, so I'm going to move it to the bottom. So all we're doing is flipping some numbers across this bar and simplifying. So we still have a Y to the 10th power on top. We still have an X to the 2nd power on top. And then the 6 is down here now with a +2. The X is down here with a +4. And the Y is up here with a +6. Now we can add them together, okay? Because Y to the 10th times Y to the 6th, that becomes Y 10 plus 6, right? If they're in parentheses, if one's inside the parentheses and the other is outside, we multiply them. But if they're just next to each other being multiplied, we only add them, 10 plus 6, okay? 6 squared is 36, and then X 2 plus 4, okay? Y to the 16th over 36 X to the 6th. One more. Let's distribute everything. I need more room for this. All right, I'll start way up here. 4 to the -2, a to the 3rd to -2, b squared to -2. Okay, I'm just going to start distributing over b to the -6 to the -2, c to the -2. Okay, 4 to the -2, a 3 times -2, b 2 times -2 over b -6 times -2, c -2. Now let's simplify the exponents. 4 to the -2, a to the -6, sorry, because 3 times -2 is -6. 2 times -2 is -4. -6 times -2 is -12. Sorry, +12. And then c remains a -2, okay? So now we know which ones are negative and which ones are positive. This is a good time to decide which ones you're going to move across the fraction bar. Ooh, everything on top has to go down. Huh. All right. So on top, all we will have is that C2, C squared, okay? Down here we have 4 squared, a to the 6th, b to the 4th, and the original b12 that didn't move. Okay, now we're just going to simplify this. C2 over, now we can say 4 squared, I know is 4 times 4, which is 16. A to the 6th, b, and then we're going to add 4 and 12. So that becomes c squared over 16, a to the 6th, b to the 16th. Final answer. So we went from this to this using the rules of exponents. And here our final answer was y to the 16th over 36x to the 6th. Simplify by writing the following expression with positive exponents only. All right. So let's distribute that -2. 3 to the -2 raised to -2. A to the third raised to -2. And then B raised to -2. Over 3 to the -4th to the -2. A to the 7th to -2. B to the -3rd to the -2. Okay. Let's multiply those out. Okay. And maybe I'll use a different color just to, just so it's easier to see as we change. So now we have 3, -2 times -2, A, 3 times -2, B, -2, over 3, -4 times -2, A, 7 times -2, B, -3 times -2. Now we're going to multiply all of those exponents, okay? So I will have, and I'm just going to move it over a little bit over here so I can do 3 to the 4th, A, that's terrible because that was look like 34. 3 to the 4th, A, 3 times -2 is -6, B, -2. 3 to the 4th. On the bottom, we have 3, 4 times 2 is 8, and a negative times a negative becomes a positive. A, 7 times -2 is -14. B, -3 times -3 is +9. Sorry, we wrote that wrong. I wrote that wrong. That's a 6. It was a -2, and I wrote it as a -3. All right, so we have 3 to the 4th, A to the -6, B to the -2, 3 to the 8th, A to the 14th, B to the +6. And right now, since we only have one exponent for each base, now I can start moving them. I need to move this A up. I need to move this A down. I need to move this B down. Okay. 3 to the 4th, A to the 14th, over 3 to the 8th, A to the 6th, B to the 2nd, B to the 6th. Okay. Three to the 4th means I have 4 3s, right? Three to the 8th mean I have 8 3s. So that becomes 3 to the 4th on the bottom. Okay. A14, so I have 14 on the top, 6 on the bottom, right? So here we just subtract. The difference between 4 and 8 is 4 on the bottom, right? The difference between 6 and 14 is 8 on the top. A to the 8th. Okay. And then B to the 2nd power times B to the 6th power means we just add B 2 plus 6. Okay. And just to be clear about that A, we had 14 A's. And then we had 6 A's. So we just canceled them. Canceled the 6, which is the same as subtracting the 6 from the 14. You get an 8, okay? So the 3s, we would just subtract the 4 from the 8 and you get 3 to the 4th. So my final answer is a to the 8th on top, 3 multiplied by 3 4 times, or 3 to the 4th, and then b to the 8th. 3 to the 4th is just 81, if I put it in my calculator. So that's my final answer. A to the 8th over 81b to the 8th out of that. All right, example 6. Simplify, assume that a and b are integers and that x and y are not 0. This is not going to be in your homework or on any exams. This is not like exactly necessary for this class, so I'm not going to do it. So don't worry about example 6. Okay, just remember and put on your note card the 5 exponent rules. All right, so for exponents, x to the m times x to the n is x m plus n. X to the m divided by x to the n is x m minus n. Okay. X to the m raised to the n is x m times n. Anything to 0 is 1, unless it's 0, then it's 0. And then if you have a negative m, if you have a negative exponent, you create the reciprocal and it becomes positive. Those are the exponent rules. All right, thank you guys.